In part C of this question, we are told we want to receive a radio signal from the base camp. The signal strength is given by the equation S equals W dot A quantity squared, where S is the signal strength, W is the wave vector, and A is the antenna vector. If the wave vector is pointing straight at you from the base camp, in what directions could you point the antenna to get the strongest possible signal and the weakest possible signal? The main concept involved in this problem is the definition of the dot product. At the end of the hike, you are some distance out from your base camp. The vector W points directly at you. Your task now is to determine in what direction the vector A should point so as to get the strongest possible signal and the weakest possible signal. Define theta as the angle between the vector W and A. Recall that the values for cosine can range between -1 and 1. This means that the values for cosine squared will range either between 0 and 1. This function s will be maximized when cosine squared is equal to 1 and will be minimized when cosine squared is equal to 0. To get the strongest signal, we let theta either equal 0 or 180 degrees. When theta is equal to 0, cosine is equal to 1, and cosine squared is also equal to 1. When theta is equal to 180 degrees, cosine is equal to -1, so cosine squared is equal to 1. These two angles occur either when the antenna vector is pointing directly at W or directly away from W. So we get our strongest signal when the antenna vector is either aligned or anti-aligned with the vector W. To get the weakest signal possible, we let theta either equal 90 degrees or 270 degrees. When theta is equal to 90 degrees, cosine is equal to 0, so cosine squared is also equal to 0. The same is true when theta is equal to 270 degrees. In this case, cosine is equal to 0, cosine squared is also equal to 0, and this whole function is again equal to 0. These angles correspond to when the antenna vector is perpendicular to the W vector, either in this direction or this direction. In conclusion, to get the strongest signal, we align the antenna vector either in the same or opposite direction as the W vector, and to get the weakest signal, we point the antenna vector in a direction perpendicular to the W vector.